Welcome, ladies and gentlemen, to your very first note guide of pre-calculus. We're going to number this as PN1. P stands for pre-calculus, N stands for notes. So PN1. Functions and their properties, section 1.2. Notice this isn't 1.1 in the textbook. We do not cover the textbook from cover to cover. We actually are aligned to the Common Core and aligned to the UW system. So just kind of keep track of how those section numbers kind of change as we go. Now, you guys have studied functions a lot. So this is really a lot of, it's going to be a quick review, but it's kind of one of those where I think it needs to be said so that you're not coming in completely cold. So what is a function? The definition is for every, and I'm going to make this a little bit, I seem to write a little clearer if I zoom it in a little bit. For every x, there is a unique, this is kind of my word, I like using that word unique, y value. And I'm going to shrink it back down. I write better when I do it that way. So what is a function? It's for every x there is a unique y value. So that's just something you've heard many, many times. What notation do we use? Well, we use function notation like f of x or g of x or h of x. And what this is saying is that, like this one right here, the function, the f function is defined over x. So f of x, or f is a function of x. Okay, so just kind of saying things you already have seen before. Same thing here. I know you've seen these tables before. This is an example of a function here where every x has a unique y, and this is not a function. Here's where you know this x right here has two y's. I sometimes, when I teach it in Algebra 1 back in the day, I would say it's kind of like this guy right here is kind of dating this girl over here and this girl over here, and you know what, that's not a good idea. That's not going to be a good relationship. So for every x, it needs to have a unique y. Now, with that said, if you look over here, notice the girl here, if that's what we're going to use for an analogy, is two timing. So let's not get into the whole logistics here, but I'm just letting you know, for a function to be a function, every x has to have a unique y, and in this situation, obviously not unique right there because of that situation. Okay, so not to get too technical here, if you need me to kind of get into that a little bit more with you, like I said, I know you've heard it in Algebra 1, you've heard it in Advanced Algebra, and now again in Pre-Calc, so let's kind of move on. Vertical line test, also something you've seen a lot. It says if no vertical line intersects the graph in more than one point, so first of all, it's a vertical line, and if it doesn't intersect at more than one point, then you know what, it's a function. So what I always tell students is this: if you're given raw data, use the visual example like we did in the top. If there's a graph, or if it's a quick accessible graph, definitely use the vertical line test. It's super easy. You know, you're just doing vertical lines, and if it's only intersecting, you know, here it's just intersecting once. Is this a function? Yes. So yeah, that's a function. You know what? Same thing here. This is a function because, again, it passes the vertical line test, which means it's only intersecting at one spot. And this right here, look at, it's definitely intersecting at more than one spot in that situation, which is makes it not a function. So at any given vertical line, now don't get me wrong, here it's only intersecting once. Yeah, I get that. But if at any point a vertical line hits more than once, it is not a function. So this is not a function. Okay, this guy needs to think. Okay, so again, review. Let's talk about domain and range really quick. The domain is a set of all input values or x values, so all x values that make sense or are defined. So all the x values that are defined over the whatever the function or whatever the situation is. The range is a set of all y values or outputs or dependent variables that make sense or are defined. So let's kind of get right down here and kind of show how that works. Again, I'm going to just tell you a trick that I do. If you ever get confused with domain and range, This is not fancy by any means, but X comes first in the alphabet when you compare it to Y. And if you look at domain in a dictionary, obviously that would come before range in the alphabet. So these two tie together. That is completely not a very mathematical way of remembering things, but I have a lot of math in my brain, and that's one way I remember it. So X is always associated with domain, and Y is associated with range. Okay, so it says down here, it already gives you a graph. It says name the graph, give is it a function, and then give the domain and range. So the name of the graph, this could be any kind of even power. It could be y equals x squared, which is a quadratic. It could be a fourth degree, sixth degree, a hundredth degree. I mean, we could get fancy, and actually, we don't have a scale here, so we don't know specifically what the equation looks like, but we do know that the shape of that U is definitely a parabola, and yeah, you need to know that word, and you need to be able to spell it, hopefully, correctly as well. Is it a function? Yeah, all parabolas are functions, so yes. And again, you can do a vertical line test if you want to think of it that way. Now, the domain. I know in advanced algebra you were taught, you know what, the domain is all real numbers. And you know what, that is great for advanced algebra, but we kind of put you up a bit. So I'm just going to say this is what they expect in advanced algebra. But in pre-calc, here's what we expect you to do. We expect you to use interval notation. Notice this down here, it says always use interval notation when describing the domain and range. This is because you're in pre-calc, and we have to get you kind of used to that notation. So what is interval notation? Well, we're looking at where x is defined over the axes, and really, if it's all real numbers, you're talking about that it's defined from negative infinity all the way to infinity. Now, it's interesting because if you've taken intermediate algebra, that is taught. This interval notation is taught in depth and intermediate, but a lot of times in advanced we don't see it. So anyway, so this is interval notation right here, and this is what we would expect you to do in pre-calc. Okay, so the range, again, in advanced algebra, you would say, hey, you know what, it makes sense for all y values greater than or equal to 0, and that is not wrong, but to be completely compliant, if you will, you need to do interval notation. That means y makes sense or is defined starting at 0, so we do a closed bracket, not a parenthesis. A parenthesis is where you're kind of going up to a value but not equaling it. A closed bracket, or a bracket, excuse me, you're starting at 0 and going all the way to infinity. Now, infinity doesn't ever end, so that's why we use a parenthesis for that. So I'm just going to let you know again that when you have a bracket, this means equal to, like it starts there and is equal to that value. If for some reason it was close to 0 but not actually equaling it, then you would use the parenthesis. And we have an example here later on in the note guide, so no worries that way. So if this is the first time you've seen interval notation, no worries. I talk about it all throughout this note guide, and we talk about it continually throughout the course. So let's kind of do this one down here. Name of the graph. Folks, this is a square root function, and the reality is there isn't a fancy name for it, so I call it a square root function or square root graph. Okay? And again, you dealt with these a ton last year or whenever you took your advanced algebra, so we're just kind of reiterating what you already know. Is this a function? Yeah, if you take a vertical line test to that, it's going to pass, so yes, it's a function. What is the domain? Well, the domain we have, it looks like it's starting here at -3 right there. That looks like -3 to me. So we're starting at -3 where it's defined, and we're going to positive from there. So since it's actually equaling -3, we are going to close that bracket, or we're going to use a bracket, and we're going to say, hey, we're starting at -3, and we're going positive on the x-axis all the way to infinity. It doesn't stop. That's the domain. The range, well, where is the range defined? Well, again, you would have said all values that are greater than or equal to 0. Well, that's exactly what we're going to say. We're going to start at 0, because we want to actually start there, and we go to positive infinity. So the more you use this interval notation, the better you get at it. And there's positives and negatives to it. It's much faster sometimes to use what you did in advanced algebra, but otherwise, interval notation is really helpful with communication in upper level classes. So we make sure you know both. Okay, so that's really kind of getting into stuff you've clearly have seen before, just talking about functions and kind of hopefully jogging that memory about domain and range. So when you flip your note guide over, I'm going to first mention that this A has no meaning at all. It's just not supposed to be there. So it says, find the domain algebraically before graphing. So you will, in pre-calculus, very much like advanced algebra, you will always have a calculator and a no calculator assessment. So when it says to make sure you can do it algebraically before you graph, you can kind of make the conclusion that this would be an example of what would be on a no calculator part of an assessment. The graphing calculator is super, super helpful, and it has its place, but we need, or I need, to make sure, again, you can do everything. That's one of the privileges of me teaching pre-calculus to you. So this is a huge math rule, and many of you will probably remember this, but it is a biggie, and we always go back to it over and over again. You cannot have, and it says big math rule, the number under a square root cannot be negative. You know that, because if you have a negative under the square root, that actually is an imaginary number, and then you deal with pulling out the I and all that kind of good stuff. So for it to be a function which can be graphed and it's defined on the xy axes, you cannot have a negative under the square root. So how do we do that algebraically? Well, for the domain, what I do is I take this expression under the square root symbol, which is x minus 2, and I know that it cannot be less than 0, but it can equal 0. So let me just kind of say this, that just kind of be careful with what you're doing here. Of course, I am obviously making video, and of course the phone's ringing, right? So we cannot have, like, we can have 2 be under the I'm now getting rid of that. We can have 2 under the square root, or this square root, because 2 minus 2 is 0, square root of 0 is 0. So that's okay. So we don't have to have an equal sign here, because if we put an equal sign, that means 0 is not defined and 0 is defined. So we just are talking about all values less than 0. So this is what I do, is I take the expression under the square root and put it less than 0. I solve it, or you can think about it logically too, but I'm just showing you this algebraically in case you get ones that are a little bit more challenging and you need to use your algebra skills. So what this is saying is x is defined for all values less than 2. So now what we are doing is we are going to put it in function notation, or excuse me, interval notation. So we know, and again, you can't use your graphing calculator, but you should know that this is shifted 2 on the x-axis, and all square root functions kind of look like that. And so we're talking about that x makes sense at 2, and goes all the way to infinity. Now you're probably wondering, well, why did I do this over here? Well, I know that this is what it can't be. So it can't be less than 2. You can write that notation that I just did, or you can write a note to yourself. This is what it can't be. So you can just use your, so whatever you want to write on your note guide to make sure that you remember why we did that. So you can't be that, or you could again say x cannot be less than 2. So anyway, I'm sorry, I'm going to come back up here. Domain starts at 2 and goes all the way to infinity. Again, infinity, we use the parenthesis. I'm going to say something about the range. Range, the easiest way to always do range is heavy-duty ranges, like graphs that you don't know. Like this, you should know how to sketch it really quick and be able to say what the domain and range is. But if it's something you hadn't seen and you need to graph it and look at it, that's the best way to find the range. So the graph is really the best way to find the range, okay? So looking at just the sketch I made over here, I'm going to actually change the color so that you can really see my sketch right there, okay? If you look at that, you can see that the y value makes sense for y is greater than or equal to 0. And so if that's the case, when we do our function notation, obviously we want to start at 0 and we want to go to infinity. Now if the graph, just for fun, let's do this. If the graph instead, actually let me do a different graph because I don't want to get you confused. If the graph instead was this, where it had a negative in front here and it reflected across the x-axis, the domain would be the same, but the range instead would be starting at 0 and going to negative infinity. You can do it that way, which kind of messes with people's minds. I tend to think that you're going from negative infinity all the way to 0. This is definitely the more proper way. You're going from the smallest number, which is negative infinity, all the way to 0. And we again will continue to do the domain and ranges. It's just the more you see, the better you get at it, and the more you practice it, the better you get at it. So actually, what am I going to? I'm going to do this here because I don't want to screw you guys up and with your. If anyone's looking at my note guide, there we go. Okay, so let's come down here to this example. Give me just a minute. Let me put myself back in my color here. And then I'm going to move this up to right there. Okay, so it says g of x is equal to 2 over x. Here's another big math rule. The denominator cannot be 0. Otherwise, folks, you have an undefined function. If you take 2 divided by 0 or any number divided by 0, it's going to be undefined in your calculator or it'll error. That'll be true until you get to calculus, by the way. In calculus, we talked about the L'Hopital's rule and how we can still deal with that. But anyway, just always that idea that there's always more math to learn, right? Anyway, so the name of that graph, well, you know what? All these types of graphs look the same-ish. They're called inverse variation, or I tend to like calling, well, the graph itself is called a hyperbola. Hyperbola. That's how it's, but it's hyperbola. Are hyperbolas functions? Absolutely. Yes, they are functions. And if you look at it, and let me do a vertical line test on it. Here it's only hitting once. Here it's hitting once. If you go along the y-axis, it doesn't hit anything. And then again, it's hitting once. Now here it gets very steep, but it still is just only hitting once. So it's definitely a function. And so what is the domain? Well, the domain, this is where I will say the other notation is much better, because you would just say, hey, you know what? It's defined for all real numbers except that x cannot equal 0. But with interval notation, what we're going to do is say, hey, you know what? We're starting from negative infinity, going all the way to 0, but not actually equaling 0. So we better not have a bracket there. But then we have to go to the other side of that 0. So think of this as going to the negative side of the 0 and jumping a little bit to the positive side of the 0. Notice parenthesis again, all the way to positive infinity. This right here is called union. And hopefully you've been exposed a little bit to that, but if not, that's okay. That's a union. And again, this parenthesis right there, and I'm going to make this big so I can kind of write it as semi-neat, means not including 0. And that's kind of a big deal. So that's actually our first example like that, which is why I want to make like a big deal out of it. So we've been using the parentheses for infinities, but we've not had one where it's not including. So we're going all the way up to 0, but not actually equaling 0, because that's where the asymptote is, and I know you've studied those quite a bit, and that's so it's converging on 0, but never ever actually touching that x equals 0. Well, the range is very, very similar with the same reasoning, so I'm going to kind of speed it up here a little bit. So I'm going to switch over. So I'm going from negative infinity to 0, because y cannot equal 0. We know y does not equal 0. And then union 0 to infinity. Okay. Now we have kind of an interesting one here. So this one, if you look at that, let me just erase that for a minute. This one is kind of a mix of a little bit of everything. So the first thing I'm going to say is you can see that x cannot equal 5. Because if x equals 5, you're going to end up with 0 in the denominator, and that's your rule, big rule number 2, right? The other is that x cannot be less than 0, because if it's less than 0, because of this part right here under the square root, you're going to end up with a negative. So here, that's caused by the denominator, and the x is less than 0 is caused by the numerator of that square root. Okay, so that's what we have going. Now, that's what you can't be. So now let's talk about what it can be, because that's really the defining difference between the old notation and the new notation. So interval notation, notice how long this line is. It's because we have some writing to do here. Okay, so first of all, when you think about this, you can't have any x values less than 0. And again, you can use your graphic calculator to look at it. Sometimes that does help people out. But I'm just letting you know you can't have x is less than 0. So we're starting at 0. Now the question is, are we starting at equal to 0, or do we have to, so do we want, sorry, I'm kind of stuttering here. Do we want this or do we want this? That's what we have to decide first. And because all values less than 0 are going to be undefined because they'll be negative, but if I put 0 in for x, would it be defined? And the answer is yes. Square root of 0 is 0, 0 over anything is 0, and life is good. So I'm going to just say that we are picking the bracket because we want to actually start at 0. And then, so if you want to think, and again, you can graph it in your graphic calculator. So you're starting at 0, you're going all the way to 5, but it can't equal 5. So what we're going to do is we're going to say, hey, you know what, we're going to get very close to 5, infinitely close to 5, but not actually equaling because it will be undefined. And then we want it, so we're coming from the negative side. We're going to get into limits in the future. So we're coming from the negative side of the 5. We're jumping over to the positive side of the 5. And then we're going to infinity. So that is how you're going to write the domain. And of course, it would be much easier if we could just do this right here, but that's just not, actually, it's just not very clear. Where this is very clear. This is where the x is defined, where it makes sense. So this is where the interval notation has a little bit more bite, or a little bit more communication to it. Okay, so I have to remember where I'm switching over here. Yes, so this will be my, yeah, okay. So we're going to talk about increasing and decreasing here just super fast. And then from there, I am going to, actually, you know what? I'm sorry, it sounds kind of weird, but that's it. I'm going to stop here and we're going to do part B with the extrema, because it kind of increasing, decreasing, extrema all go together. So thank you for tuning in, and then when you take a pause, go to the restroom, get a drink of water, check out my part B, okay? And of course, any questions you have, we'll take care of in class. Take care.